All right, good morning, guys. So I wanted to record myself just saying a little bit about this summary slide. So, to my memory, although you can tell me if I'm wrong, I had gotten through our Nomenclature Chapter 7 PowerPoint slides with both of my honors classes. We had talked about ionic nomenclature, naming ions. A lot of it was really simple, just saying, oh, that's my sodium ion, or if it's a nonmetal, being able to drop the ending and gain IDE. We talked about our polyatomic ions. You got your polyatomic ion list. You're going to be working with them a little bit today. So, to remind us about it, I thought it might be better to hear it in my voice. But on your Chapter 7 PowerPoint notes, your slide 16, which is the last blue slide. So, again, we're just in section 1 of Chapter 7. We're going to be doing a bunch of practice with nomenclature in this section. So on slide 16, we have this summary slide. So usually in class, I would project this summary slide as you guys worked in groups on some, like for example, today's little worksheet that I'll have you do. So this is a great quick reference for those of you that might be looking just to be refreshed about nomenclature. So if we take a look here, I've got all three types of nomenclature that we're going to be looking at. So we're looking at binary nomenclature, which means there's going to be two parts to it. So this is only going to be for ionic and covalent. Now, the reason we have three flavors is because we have ionic with a set charge. So those are my main group elements that have a predictable charge, like our alkali metals or alkali earth metals, and then silver, zinc, and aluminum. We said aluminum is that 3 plus. It's the third column of your main group elements, and it has that 3, 2, 1 decreasing kind of image on your periodic table. So we have ionic with a set charge, and then we have ionic without a set charge. So that's thinking about the transition metals. Every other element on the periodic table, because it has more than one ion that could form, you have to either infer it from a formula or report it back using nomenclature. And then lastly, covalent compounds. All of the covalent compounds that we're going to be looking at will only have two elements in them. If you notice that you have some chemical formula and it's looking large, that's probably because there's a polyatomic ion in there and you haven't memorized that polyatomic ion yet. But we'll get to a point where you'll see, C2H3O2 and you'll say, oh, that is acetate. So it won't look as daunting as we get more and more practice in. But anyways, on this slide, you have some bullet points. They remind you of just what I was talking about. Ionic compounds with a set charge. These cations must be main group metals. I remind you about aluminum, zinc, silver, and your only positive polyatomic ion, ammonium, NH4+. Because ammonium is a polyatomic ion, it's not going to change. It's always going to be NH4+, which is also why we describe it as having that set charge. The anion can be any main group nonmetal or polyatomic ion. And same thing for that. If it's a negative polyatomic ion, it's not going to change. So it can act like that nonmetal, but we would have a known set charge to it. And again, we're going to be doing some practice. I have you guys doing polyatomic ion practice today. But it is expected that as a chemistry student, you are memorizing these polyatomic ions. So take some time. Look at those flashcards. If you haven't made flashcards already, I would encourage you to do so. And how we name these set charge, we say we name the metal, and then we drop the ending of our nonmetal. So this is sodium chloride. So the reason why sodium chloride is only sodium chloride is we have sodium, Na plus has a set charge as an alkali metal. Chlorine, halogen, set charge as a -1. So we take that chlorine, becomes chloride, smush it together, sodium chloride. If we look at that formula, sodium chloride, any other chemist out there would say the combination between sodium and chlorine has only one option because these atoms have a set charge. There's a set way that they can come together. There's only one option. Next, ionic compounds without a set charge. Now, although some cations, some transition metal, may have more than one opportunity to form an ion, we could be looking at Fe2 plus or Fe3 plus. Now, just because it has different cations that can form does not mean that we are looking at a sort of like multiple combinations for any ionic compound. So we still need a neutral compound. We still need the positive to cancel out the negative. It's just that you might see different variations of that one element doing that in a couple different ways. So we still name the cation. The anion is still going to be named, dropping the ending, gaining IDE. If it's an element, if it's a polyatomic ion, you just name the polyatomic ion like we had done for set charge. The difference with the non-set charge, and also the thing that's going to stand out to you when you recognize it, is the Roman numerals. So just like when we were talking about naming a ion, when you're naming a um, sorry, I lost my train of thought. When you're naming an ionic compound without a set charge, you have to show that in Roman numerals. So you're going to use parentheses and Roman numerals, and it's only ever going to be the Roman numerals that are describing the charge of that metal cation. The common misconception is to think, oh, that's the number of atoms of my metal cation, but that would never be true. Or I would say, if it were true, it would be coincidentally true. All right. And finally, our covalent compounds, these are going to be using prefixes. So we have them on the slide right before this. And we are just going to use it for our elements. So that is why water is dihydrogen monoxide. There are 2 hydrogens and 1 oxygen. So it is particular that you tell your reader about that, because the law of multiple proportions states that, particularly with covalent compounds, because all they need is an octet, and they can do that in many different ways, depending on the combination of atoms that are in some substance. You just have to convey to your reader how many atoms you have. So we'll see some more examples with that, but we are just looking, I think, on today's practice problems at ionic with a set charge, and some polyatomic ion practice.